Here, our goal is to determine the size of angle X. So we want to calculate the size of angle X. Notice that angle X is right here. Angle X is one of the three angles that is inside of this triangle. So angle X is inside of this triangle. And notice that according to this useful geometrical rule, it states that angles inside a triangle add up to 180 degrees. And so that means that angle X plus this angle that measures 27 degrees plus this 53, if we add them and we combine them, they're supposed to be equal to 180 degrees. And so in order to determine the size of angle X, we're going to add 27 and 53 and then subtract that sum from 180 to get the size of angle X. And so we have 180 minus 27 plus 53 degrees. 27 plus 53 is definitely 80 degrees. And so that means that X is going to be equal to 180 minus 80. And so X is going to be equal to 100. And so that means that the size of angle X is 100 degrees. Next, let's move on to angle Y. Here, our goal is to determine the size of angle Y. Notice that angle Y is right here. Angle Y is one of the angles that is inside of this second triangle. This triangle that's right here. And notice that according to this useful geometrical rule, it states that angles on a straight line at a common point add up to 180 degrees. And so that means that if we look here, we have these two angles that are on a straight line and they are at a common point. And we know that angle X is 100 degrees. And so if we're trying to figure out what is the size of angle Y, we're gonna subtract 180 from 100 to get the size of angle Y. And so angle Y is gonna be equal to 180 degrees minus 100 degrees. And when we subtract, we get that angle Y is equal to 80 degrees. And so that means that the size of angle Y is 80 degrees. Next, we move on to angle Z. Now, angle Z is right here. And notice that we're dealing with an isosceles triangle. We know that we're dealing with an isosceles triangle because if you look here, we have a stroke here or a line here, and a stroke here or a line here, and that indicates that these two side lengths are equal. And if these two sides length are equal, then that means that the bottom, that here, right here, this angle and this angle, these two angles must be equal. So if the side lengths are equal, right, the angles here must be equal. And if you have a triangle where the two side lengths are equal and the two base angles are equal, we say that we're dealing with an isosceles triangle. And so if we want to determine the size of angle Z, we already know angle Y is 80 degrees. If we want to figure out the size of angle Z, we know that this is 80 degrees, and we also know that this is 80 degrees. All right, we also know that this is 80 degrees. And so that means in order for us to determine the size of angle Z, what we have to do is we have to add 80 degrees and 80 degrees. And once we add them, then we're going to subtract them from 180 degrees. Why are we subtracting from 180 degrees? Because angles inside of a triangle add up to 180 degrees. And so that means that if we add 80, Z, and 80, it should add up to 180 degrees because angles inside a triangle add up to 180 degrees. And so in order to determine the size of angle Z, what we're going to do is we're going to add 80 degrees and 80. So we add those two. And then we're going to subtract that from 180. And so when we do that, it's going to be 180 minus 160, and 180 minus 160 is going to be equal to 20 degrees. And so that means that the size of angle Z in this question is 20 degrees.